Hello. Today I'm going to be going over ResView. My name is Cypernov Kochmurdy, and I'm the project leader of the ResView project. So what is ResView? ResView is a visualization application to help you understand what is going on in Resilient DB, what is going on in the consensus protocol, and how are the different replicas communicating with each other, and how are they actually going through this entire process, because it's a very complicated process, and it's very hard to understand for a lot of people. So first, we're going to be on the homepage. So the homepage is essentially just going to have what is ResView, just some details about it, and what is PBFT, just some details about that. The actual application is started by running npm start on the React file, and then we get this application. So the first thing we're going to do is we're going to go to the visualizer. So when we load up the visualizer, you're going to have three tabs. You have the transaction form to actually send transactions. You have the PBFT diagram, and you have a messages versus time graph, which is how are each of the replicas collecting messages. So here we have three tabs. Let's not worry about select transaction for now. So we have get and set transactions. Before we can actually do any of this transaction, first we're going to need to actually start up the backend for all of this. So to start up the backend, it's pretty simple. In the backend Resilient DB, you're going to start the KV service, and then you know that it started up because you're going to have 4 open messages here, which means that all of the WebSockets connected. Next, you're going to want to start up the SDK, so you can actually use the API to send the transactions to the backend. If we start it up, now it's going to be running. So now that we have those two services started up, we can actually start doing everything we want to with this application. So let's start by sending a set transaction. So we're going to set key 1 to value 1, for instance. So if you notice, here we have the responses from the backend. So we have a message from each of the replicas containing the data over the course of the transaction. So this is from replica 1, this is from replica 2, this is replica 3, this is from replica 4. And this is the real-time data. This was accumulated over the course of the actual transaction. If we go to the PBFT diagram, you can see that this is the actual flow of how the PBFT protocol went. So the client sent it to the primary. The primary broadcasted the prepare message to all of the other replicas. The replicas communicated their prepare messages and then their commit messages to make sure that they have the same transaction as everybody else and that the other replicas were also prepared. And then they all send a reply back to the client with the response. If we go to the messages versus time graph, so this is going to be the accumulation of each of the messages across the replicas. So we have all 4 replicas shown, but it's kind of hard to parse what's going on. So what we can do is we can actually toggle some of these replicas to not have to see them. So here we're just looking at replica 1 and replica 2. So if you notice that replica 1 actually collected all of its messages prepare messages a lot faster than replica 2 did. There was a very big difference in time, almost half the time. And this is the point of the prepare message versus time graph. You can actually see the difference in how the replicas are communicating or collecting messages. This might be an issue with the network. This might be an issue with how they were sent. But regardless, you can actually see that there's a pretty big difference. Similar thing with the commit messages. You can see how each of the replicas collected their commit messages and compared them. But now, what if we want to test a different case? What if we want to test when a replica is actually faulty? So you can actually toggle a replica being faulty through this button prompt right here. So let's take, for instance, replica 2 is faulty. And let's send another transaction. For instance, let's send a get transaction for key 1. If we open the console back up, and we open this, you can see we didn't actually get a response from replica 2. This is because replica 2 is faulty. It's not receiving any messages, therefore it can't communicate any messages. It doesn't know that a transaction occurred. So we only have messages from replicas 1, 3, and 4. If we go to the PBFT diagram, you can see that this is displayed here. We are sending messages to replica 2, but replica 2 has no idea that it's receiving messages. It's faulty. And so no messages are actually coming out from replica 2. So it's not sending any prepare messages, it's not sending any commit messages, and it's not sending any replies. Similarly, if we go to the messages versus time, you can see that we only have 3 replicas. And if you notice, I want to draw attention to this number right here. Only 3 commit messages were collected, and only 3 prepare messages were collected this time. Now let's say that I wanted to go back and compare this to the original transaction when all the replicas were fine. You don't actually have to rerun a transaction with all the replicas being fine. What you can do is you can go to select transaction and you can choose transaction 1. Now, if I go to the PBFT diagram, you'll notice this is all of the data from transaction 1. You can see that replica 2 is actually sending out messages in this case. If I go to messages versus time, this is the prepare messages from transaction 1. And you can see that 4 prepare messages were collected here. The ResView basically gives you this easy way of interfacing with the backend while also giving you more data on what's actually happening thanks to these replica or these graphs showing the PBFT diagram and the prepare messages. And that's pretty much the entire application. Thank you for watching.